Look at this spatula. Just a regular tool, mix and spread ingredients, right? But wait, this one is floating in space for some reason. So there's this astronaut named Pierce Sellers. There he is. He's up there in space, just doing his thing, when all of a sudden, he accidentally drops his trusty spatula. Let me give you some context. This all happened during the Space Shuttle Discovery's STS-121 flight back in 2006. They were on their way to the ISS on a mission to test out some new safety techniques. And now this spatula is just a tiny drop in the ocean of space debris. Humans have been exploring space for over half a century now. We've left all kinds of random stuff up there, from itty-bitty bolts to entire space stations. We've chucked a ton of things into the great beyond. Most of it burns up in a spectacular blaze as it re-enters Earth's atmosphere. But some bigger pieces can be a real danger for astronauts and their fancy spacecraft. Imagine accidentally crashing into a massive hunk of space junk. There are other weird things found in space. In November 2008, astronaut Heidi Stefanishan Piper was out on a spacewalk trying to fix a jammed gear on a solar panel. Suddenly, she lost her grip on the bag. That bag weighed around 30 pounds and was filled with all sorts of cool stuff, like grease devices, a scraper tool, and bags for debris. And it was pretty pricey for a tool bag. It cost around $100,000. Sometime later, amateur astronomers spotted the bag floating around in space. If you're in North America, you can even check if the tool bag is passing through your little slice of the sky. Just hop on over to spaceweather.com's satellite tracker and see if you can catch a glimpse of this interstellar tool bag. By the way, if you need to twist some wires in space and you don't have pliers, well, you may stumble upon them as they're free floating in space too. Back in the day, when astronauts were just getting their space groove on, they tended to misplace things up there. During his first spacewalk on the Gemini 4 flight in 1965, Ed White, a famous spacewalker, accidentally let go of his glove. That glove decided to have its own adventure and hung out in orbit for a whole month before getting roasted in Earth's atmosphere. So not all debris is there to stay after all. So, space junk is basically all the stuff floating around in space that humans have left behind. Before we got all curious and started exploring, there wasn't any space debris hanging around. Imagine space junk as a little kid who just learned how to walk and play with their own toys. When they couldn't walk yet, it was easy for the person watching them to keep the play area clean. They were in charge of taking out the toys and putting them away. But now that the kids can walk, they can grab as many toys as they want and make a huge mess on the carpet. Well, it's kind of the same with us humans exploring outer space. We've sent all sorts of cool gadgets, like cameras, rovers, and rockets to check out what's out there. But we haven't really thought about bringing them back to Earth. And that's where the problem comes in. All this space junk floating around could mess up outer space, and even our planet. When we think about outer space, we often imagine vast open spaces that are yet to be fully explored. Humans have only discovered a tiny 5% of the universe. But here's something they might not always consider: the impact of all the cool gadgets they send out there. Believe it or not, as of May 2022, we've got more than 5,000 satellites orbiting Earth. Over 5,000 opportunities for these machines to go haywire, get lost in space, or even worse, create a bunch of debris that could harm both outer space and our lovely planet. There's at least 3,000 satellites just hanging around up there, not doing anything useful, and nobody seems to be bothered about bringing them back home. And what if one of these inactive satellites accidentally collides with one of the thousands of other space junk pieces orbiting our planet? It will result in a catastrophic disaster. We're talking about a crazy release of toxic substances that could wreak havoc on our poor Earth. Space junk can mess things up for scientists trying to make important discoveries. It's not just floating around aimlessly in space or posing a threat to Earth. It can hinder their chances of success. Even the moon has its fair share of junk, which Neil Armstrong definitely didn't encounter when he landed there in 1969. Think of it like this. Imagine you're an artist trying to create a huge painting. It's hard to do that if there's a bunch of old paints, brushes, and other stuff cluttering up your play area, right? Well, it's the same deal for scientists trying to set up camp and use new technologies for advanced missions and space exploration. They need a clean and organized space, just like you need a tidy work area. Otherwise, it's chaos. So here's the deal with space junk. It's not just about sending stuff up into the atmosphere. It's also about how far away we send it. You see, when satellites are sent over 22,000 miles into the atmosphere, it becomes a real problem to retrieve them and bring them back to Earth. And that leads to even more space junk floating around up there. Now, I know what you're thinking. How long will it take for space junk to become a major problem? Well, it might still be a few more years before it messes things up in outer space. But hey, that doesn't mean it's not a threat to satellites we have up there right now. Those poor guys are at risk of getting damaged, destroyed, or even leaking toxic stuff because of all that junk. So, space debris isn't just a problem for space exploration, but it's also a problem for us Earthlings, even though it's floating thousands of miles above us. Space junk is like that annoying neighbor who throws trash out their window and it ends up in your backyard. Except instead of trash, it's releasing all sorts of chemicals into our atmosphere that are slowly destroying our precious ozone layer. It can even ruin future space missions. Imagine this. You're all pumped up to launch a rocket into space, but nope, space junk decides to crash the party. Not only does it mess up the launch, but it also adds more pollution to our already struggling atmosphere. And if things couldn't get worse, imagine a shooting star or meteor accidentally smacking into some space junk on its way to Earth. Boom! Millions of toxic particles raining down on us, further depleting the ozone layer. Plus, space debris is becoming a real problem for space missions. In 2022, we found some space debris hanging out on Mars. The Perseverance rover stumbled upon its own backshell just chilling on the surface of Jezero crater. They also spotted a random piece of a thermal blanket that might have come from the rover's descent stage. Also, human-made space debris actually smacked into the moon in 2022. It was probably some old rocket body from the 2014 Chang'e 5T1 mission, but nobody saw that coming. It left a double crater behind. The more space junk we have floating around in low Earth orbit, the higher the chances of a cosmic collision. These collisions are no joke. They've already caused some serious satellite damage. Even the ISS has to constantly maneuver to dodge space debris. But scientists seem to know how to clean up this orbital mess. They're planning to send space vehicles armed with nets, harpoons, and even robotic arms to capture and deorbit all that junk. Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone, the size of dozens of Everests, will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalts. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide. So not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
The Earth has 3 main layers. 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
A huge meteorite enters our atmosphere, causing an explosion of catastrophic proportions. All forms of life on Earth cease to exist. A giant wave of fire wraps around the planet several times until only ash and dust remain of the green landscape.
But then again, there's another option for our planet's future. The sun could swallow it.
Wait. Who is this?
In the course of its evolution, our star will keep expanding
Am I the only one hearing this voice?
until it gets so big that it just swallows our planet without even noticing it.
Hey buddy, that's my video.
I don't think so.
Okay, alright, I'll share it with you. But let's not look that far into the future.
Whatever you say, buddy. How about the fact that the Earth will soon have rings?
Like Saturn?
Almost. Saturn's rings are made of dust and ice.
Yeah, I've heard about that. Thousands of years ago, something really mysterious happened in Saturn's orbit. The planet's gravity tore one of its satellites apart.
Yes, Saturn is a gas giant. It's 95 times heavier than Earth, so it has stronger gravity. It attracted a small moon from its orbit to its surface. Then, it was torn apart from the inside by tidal forces, like the ones between Earth and Moon. Many huge fragments stuck in Saturn's orbit. Some scientists say there was a collision of two moons there. They crashed into each other like billiard balls. As a result, both cosmic bodies turned into a pile of debris and blocks of ice.
No matter how they got there, this debris started circling Saturn. They collided with each other, turning into smaller rocks. It was a kind of cosmic blender. Rocks gradually ground into dust, and huge blocks of ice turned into small crystals. On average, the objects are in the same ratio to these rings as a human fingernail to a school bus.
And soon, similar rings will appear around Earth.
But how? I mean, we have the moon, and it's hard to imagine that it could break apart at any moment. Plus, we don't have another moon to recreate the same collision in our orbit.
Space junk. We have a lot of it. We started launching spacecraft into Earth's orbit in about 1957, and it almost always follows the same scenario.
Ah, yes. The rocket consists of several parts, a booster, or even several of them, the second stage of the rocket, and a cargo, which is contained in a capsule at the end of the rocket. The booster accelerates the rocket to almost orbit and then undocks. The second stage fires up the engines and climbs even higher to get the cargo into orbit. Then the second stage undocks as well, and the cargo capsule releases the satellite or space probe into outer space.
Yes, the first and the second stages of the rocket and the cargo capsule were disposable. That means they stayed in Earth's orbit. Over time, our planet attracted them. They entered the atmosphere and burned up because of friction with the air. But many objects keep orbiting our planet for decades. As of 2021, there are about 170 million space debris objects in our orbit. These are parts of spacecraft, like the bolts used to undock rocket stages. There are also old artificial satellites, operating ones, functioning spacecraft, and debris from collisions that had already happened.
Oh, I've heard about that. In 2009, two satellites collided with each other. Both satellites were destroyed. They shattered into about 600 pieces of different sizes.
Yes, and these sharp metal fragments are flying in orbit at about 6 miles per second. So they could make a trip from New York to London in less than 10 minutes.
Yeah, that's about the same speed at which our rockets fly. And that's about 45 times faster than commercial airplanes.
So these fragments have a lot of energy. As they collide with each other, they shatter and become smaller.
Just like the moon debris around Saturn.
Exactly.
But a bunch of metal debris orbiting faster than the speed of sound can damage our spacecraft, right?
Yes. The International Space Station has already turned on its engines to maneuver once to avoid a collision with a cloud of space debris. Sharp metal parts can damage the hull of the space station or even puncture it. Then the ISS, worth about $150 billion, would be destroyed.
So, if we keep throwing debris into orbit, we could really give our planet the rings.
And then they will be visible even during the day. They will reflect sunlight, just like the moon. And if you look out the window, you'll see beautiful stripes interrupted by the shadow that the Earth casts.
It's an amazing view. Do you want to see an even more unusual one? Imagine that our sun has increased in size by 10 times, and that process is happening right now. Our star is a giant boiler burning hydrogen. It's continually heating up, and every billion years, the sun gets 10% brighter and creates more heat. It'll heat the Earth more, and eventually, the oceans and seas of our planet will begin to evaporate. Thick clouds will completely cover the sky, turning Earth into a giant greenhouse. Our home will look like Venus.
Looks like humanity will no longer be able to live on Earth. What will we do then?
Well, we'll load all the humans and animals into spaceships and move to Mars. At that point, the sun will have warmed it up nicely. water and carbon dioxide deep in the planet's interior will begin to evaporate and create an atmosphere there. This will cause a greenhouse effect and warm up the planet enough for you to wear shorts there.
And then we'll watch the Earth become a lifeless rock with acid clouds like Venus from the surface of Mars.
Yep, but in about 7 billion years, the Sun will start to expand even more and become a red giant. In this phase, it'll become 256 times wider than it is now. So it will completely swallow Mercury and Venus, and the edge of the star will lie just in the orbit of Earth.
So our planet will just drown in the hot plasma on the Sun's surface?
Maybe. But when a star burns so much fuel, it loses weight, and so the Sun's gravitational field will weaken as well. So it won't keep the planets of the solar system as close to itself anymore. Perhaps our planet's orbit will become wider, and then Earth will become the first planet near the Sun. Some scientists believe that at this time, Saturn's moon Titan may gain conditions suitable to become a new home for humanity. Then the Sun will begin to shed its upper layers. It'll lose mass and gravity dramatically. This will plunge the solar system into chaos.
Some planets will collide with each other. Others may just fly away into the far dark space. It would be a game of cosmic billiards.
Exactly. And the final stage of the Sun's life is a white dwarf. Then our star will become the size of Earth. The planets that survive won't get enough heat from the white dwarf, and its light will gradually fade over billions and trillions of years.
Another challenge that awaits Earth in the distant future has a galactic scale.
The collision of the Milky Way and Andromeda.
Bingo! Right now, the Andromeda Galaxy is moving toward us at 60 miles per second. You could make a trip around the globe at that speed in just 6 minutes.
Yeah, you can already see the stars and gas of Andromeda Galaxy in the night sky with an unaided eye at 2.5 million light-years from Earth.
And in 4 billion years from now, the galaxies will begin the process of merging. No one could be 100% sure about what will happen to the Earth. It could be total chaos when the stars and nebulae of both galaxies collide. Then supernova explosions would go off everywhere. Like fireworks.
But this is extremely unlikely to happen. The concentration of stars and space objects in galaxies is very low. The distances between them are gigantic. It's like if you took a handful of sand and scattered it all over the planet.
The most likely scenario is that by the time the two galaxies do collide, there will be no liquid water on the hot surface of Earth. That would mean the end to all terrestrial life. Scientists believe it can happen in about 3.75 billion years.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, This is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the Collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, The rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
One iced frappuccino for me, please, and with a double shot. Now, I suspect this is something you'd never hear if you traveled 100,000 years ago to check out on your super great-great-great-grandparents. First off, you wouldn't hear anything resembling human speech for a simple reason. The early humans developed a capacity for language about 50,000 years ago. So, to talk to your ancestors, you'd need to use some of the oldest forms of human communication, including talking or making sounds, drawing or painting, dancing, acting, and using symbols. For example, if you made some weird noises like grunts or guttural sounds, it would mean you're trying to communicate with your peeps or warn them about something. Another reason why no one would grab iced frappuccino back then is that 100,000 years ago, Earth was going through a serious ice age. Who wants an icy, refreshing drink in the middle of winter? It wasn't quite a full-blown glacial period, but it was definitely way colder than it is now. The sea levels were low and there were glaciers everywhere, which made it super tough for our early human ancestors to get around. Some even kicked the bucket while trying to migrate to other areas, especially up in Northern America and Europe. Back in the day, when humans were still figuring out this whole survival thing, they chowed down on some pretty, fancy stuff. We're talking tartar steak, sashimi, you name it. Okay, I'm exaggerating a bit. It wasn't an iconic fresh dish, but raw meat. Not a Japanese cuisine staple, but a plain fish. There weren't Michelin restaurants serving fancy dishes and Gordon Ramsay recipes, but prehistoric foodies happily munched on nuts, seeds, and berries. And you know what? Their lifestyle is gaining popularity today. And there's even a so-called paleo diet. Paleo stands for the Paleolithic period. The idea is all about eating like our early human ancestors did. Some scientists believe that our genes haven't quite caught up to the modern diet that came from farming. Thanks to farming, we've got grains, legumes, and dairy galore. But it turns out that these changes in our diet happen faster than our bodies could keep up with it. 100,000 years ago, humans roaming around were basically just like us in terms of looks and DNA, but their houses were far from being modern. Actually, those were just caves. They couldn't even buy a mere bed in IKEA. Scientists in South Africa just discovered what they're calling the world's oldest bed. And no, it's not a fancy mattress with adjustable firmness settings. It's actually made of grass. Archaeologists stumbled upon mats of grass and sedge that were stacked half an inch thick on the floor of a rock shelter. And get this, the bedding is 77,000 years old. That's like 40,000 years older than the previous record holder. The mats were covered with leaves from a tree called the river wild quince, which repels pesky insects. These prehistoric folks were basically having a bed and breakfast situation going on in their cave. But let's be real, living in a cave is pretty gross. Insects, rot, and lice are just a few of the issues. But instead of bouncing to a new spot when things got nasty, these people burned their bedding and made new ones. Yeah, seems like 100,000 years ago, life on Earth was totally wild. Sure, microbes and amphibians were chillin' for billions of years before that, but things were way different back then. So, during a prehistoric trip, you could have bumped into one of the biggest mammoths ever. Yup, the Columbian mammoth was a beast. Standing at 13 feet tall and weighing over 10 tons, it had curved tusks that were even longer than its body, somewhere over 16 feet. These weren't like those woolly mammoths you see in movies with their thick brown fur. The Columbian mammoths didn't need that kind of coat, because they didn't live in the icy regions of Europe and North America. But don't let their lack of fur trick you. These creatures were massive and could have been a real threat to humans who lived near them, even though they were plant eaters. Another beast you'd stay away from is Toxodon. This land animal had some seriously cool curved teeth that gave it its name. It looked like a rhino, but with some similarities to rodents too. The last one was spotted only 5,000 years ago, and that's pretty recent in the grand scheme of things. Charles Darwin even used the toxodon as an example to explain evolution and anatomical differences. Some people think it might have been semi-aquatic, but its grass-eating habits suggest otherwise. Not only was the Earth full of cool animals, but it also had a diverse human population. There were all sorts of new species popping up left and right, and they were on the move, looking for a better place to call home than Africa's dry and dusty areas. One of those species was Homo floresiensis, aka the hobbits. These little guys were only about 3 feet tall and hunted for their food using stone tools. They were totally unknown until recently, when scientists found their remains in caves all over the world. Homo erectus were the first humans who actually looked like us. They were total trendsetters, standing upright and all. They were the first to explore outside of Africa and check out other continents. These guys were pretty smart too, making cool tools and even cooking their own food. But unfortunately, they got a little too comfortable and lazy. They didn't keep up with the changing climate and eventually went extinct. It's a shame, really, because while other humans were hustling to improve their tools and survive, Homo erectus just couldn't keep up with the times. Lesson learned: don't be afraid to get out of your comfort zone. Homo sapien Neanderthals were basically our ancient cousins who lived in Europe and Asia. They were pretty smart and used fancy stone tools to hunt and survive. But let's not get too carried away with their intelligence, okay? The media likes to hype them up as geniuses, but there's not a ton of evidence to back that up. Modern people are the only non-extinct human species. You and I are part of the Homo sapiens sapiens subgroup that roamed the Earth 100,000 years ago, too. We were so smart that we even migrated out of Africa to Europe and Asia. Our intelligence was apparent from the very beginning. By the way, the era we're traveling in was called the Stone Age, as back then people learned how to tame stones. That was a tremendously large era that started over 2 million years ago, and it only finished in 3300 BCE. Let's dive into Plombos Cave. It's a super cool spot located in the Plombos Private Nature Reserve on the southern Cape Coast of South Africa. The cave may be small, only around 430 square feet, but it's got a big history. Early modern humans were all about Plombos Cave, visiting repeatedly between 100,000 to 70,000 years ago before a sand dune partially sealed the entrance. Above the sand dune, you'll find material from the later Stone Age. The coolest discovery? 2 pieces of ochre with geometric engravings that were found in 2002, marking one of the earliest signs of symbolic communication among early modern humans. It's about 75,000 years old. And it doesn't stop there. More engraved ochre pieces have been found in later excavations, proving that this type of communication has been around for ages. Plus, they found red lines of ochre drawn on a rock that dates back to 73,000 years ago, showing that painting was also happening back then. Also, in 2008, they discovered a 100,000-year-old ochre processing workshop with a couple of toolkits at Plombos Cave. These toolkits consisted of 2 abalone shells containing an ochre mixture that was possibly used for painting or other purposes. Our technology has sure made a quantum jump since the first tool ever was invented. But just so you know, it all started with pointed stones in Plombos Cave. Yeah, probably the reason why you have the internet today is because some prehistoric dude in Plombos Cave learned how to use pressure flaking and managed to sharpen the very first stone ever. And there were some inventions in between that, but yeah,